Hello and welcome to the fact that the scientific community has failed to detect dark matter and why it's important and you should probably care about it. The YouTube video. The findings have left researchers struggling for answers. We do not understand how the universe works at a deeper and more profound level than most of us care to admit. Looking for invisible dark matter, can't find it, which suggests that the standard theoretical model used to describe the motion of stars and dark matter halos in other galaxies might be invalid. They've spent a lot of time and a lot of money. Large Hadron Collider, 30 years, $6.4 billion. I'd say you have been testing the crap out of this theory. And so you're sitting there and you're asking, well, what is dark matter? What is he talking about? I don't understand what it is that we are not finding. I don't get the importance of it. And so I should probably start at the beginning, and I should talk about the scientific community's very, very complicated relationship with gravity in general. The scientific community as the prince from Cinderella, and gravity as Cinderella herself. And so this is the beautiful dance between our scientific community and gravity. So they've been dancing now for about 300 years, and when gravity showed up to the ball, the prince was like hit in the head with how attractive she was. He just could not believe it. You are the most attractive thing I've ever seen in my life. I am drawn to you. It's so hard to get away from you, actually. So around the 300-year mark, gravity here, she sort of turns to her smiling prince and goes, "Prince dear." "Yes, honey." Hey, have you been picking up the hints that I've been dropping for you?" He's like, "Hints that you've been dropping for me? What are you talking about? Have you been dropping hints of some kind? Is something wrong?" And she goes, "Well, no, nothing's wrong necessarily. It's just that I sometimes feel like you don't really understand me, and I want you to. I want more out of this relationship than just dancing and smiling. That's all we do, and there's more to life than that. And I want to experience that with you. I want to take our relationship to the next level, if you know what I mean. Hint, hint, wink, wink." And the prince goes, "No, I don't. What's wrong with our current level of understanding? We don't need to complicate our relationship by trying to take it to the next level or anything." And she goes, "You know what? It's been a fun dance, but it's midnight. I gotta go. I'm gonna go." And the prince is like, "Whoa, you can't leave. What? Midnight? Is that your reasoning? Look, I have the smartest clockmakers in the world. I'm the prince of a kingdom. We'll build a new clock. We'll just build a new clock that never runs out of time. And then you and I can keep dancing forever, and we never have to take our relationship to the next level." And so she stands at the bottom of the steps, turns back, and yells at the prince, "How about you come find me when you figure out what I'm talking about?" And then she storms off and leaves behind her glass slipper. But she leaves. She's out. And the prince is just sort of standing there dumbfounded, looking at his scientific method, going, "What? We did all the steps right. We didn't do anything wrong. Every step of the way. It's logically infallible. Why is she mad? This doesn't make any sense." And so the prince, in a panic, he just locks himself away. And so you are probably wondering, well, what is midnight? Midnight is when we've collected enough evidence to suggest that Einstein's description of nature is likely incorrect and is probably not the best guess at all. Before I start comparing dark matter to clocks and things, and I need to maybe give you an understanding maybe of what dark matter is. This is from CERN. So, dark matter. Let's just read this right here. "Galaxies in our universe seem to be achieving an impossible feat. They are rotating with such speed that gravity generated by their observable matter could not possibly hold them together. They should have torn themselves apart long ago. The same is true of galaxies in clusters." All right, let's revisit this first sentence. "Galaxies in our universe seem to be achieving an impossible feat." Galaxies in our universe seem to be achieving an impossible feat. You're describing nature as impossible. See, that's a bit of a problem, because nature doesn't actually obey the laws of man, which is the equivalent of walking outside, seeing a bush growing, and saying, "That is impossible." That's not what you do. That's not how nature, that's not science. You don't get to do that. A matter of fact, I've actually consulted the scientific method, and it doesn't say anywhere on it, tell nature that it's impossible. Step 1, look at it. Step 2, tell it shouldn't exist. Yeah, I can't believe it. That's not a step, because that's not how it works. Like, and you just got, you guys, the scientific community just does this all the time. We look in space and they go, impossible, defies the laws of physics, this shouldn't exist. Then your theories are wrong. Nature's not wrong. You're not in charge of nature. What? Pulsar, picked up by the authorities for defying the law of physics. Wait a second. What is the punishment for something that breaks the law? How do we enforce that? We can't, because we can't tell nature. What the fuck are we gonna do? Hey, Pulsar, when we get our shit together as a human race, we are gonna totally arrest you for disobeying the laws of physics. And so the prince is just up there dancing with himself with a stopped clock, shutting out the world, shutting out reality, just whispering to himself, nature is impossible. It defies the laws of physics. We can't rely on nature to tell us how nature works. So the reason that the scientific community will not ever stray, and they'll just keep calling things impossible forever, is because they know that Einstein is right. It all comes back to Einstein's General Theory of Relativity, which he published in 1916. And it's pretty much this in a nutshell. It says, if 1 + 1 = 2, then space and time are the same thing. And so everyone kind of just said, I don't understand how that makes any sense. Could you please elaborate? And he's like, no, check out my math, right? And he goes, so if my math is correct, I predict we are going to see a warping or curvature in the fabric of space and time, where there is a mass, and then light, as it travels towards us, the curvature of space and time are going to act like a lens. And so we're going to see light bending as it travels around. And they say, yeah, that's great, Einstein. How do you prove that? And he says, oh yes, sure. So just stick with me here. This is my experiment. It's a thought experiment. It is an experiment carried out in the mind only, meaning there's no physical, you can't touch it, it's all in your head. Although instruments can neither see nor measure space-time, several of the phenomena predicted by its warping have been confirmed. And that is why Einstein is Einstein. He looked and said, we have no instruments that can measure space and time, but I predict, if you think about it, I predict we're going to find gravitational lensing. And we did, and this is what that looks like. This is what gravitational lensing looks like. And the first time we saw it was in 1919, and so everyone was like, oh my god, that is amazing that you predicted a warping effect. No one expected that. And so from there they said, well, I guess space and time really are the same force. And no one could argue with it, because to argue with it is to argue against observable evidence made by a prediction by Einstein. And so just really quick, I just want to say that, as strange as this sounds, gravitational lensing always reminds me of ducks. Like a duck, the animal, a duck. It always reminds me of this picture, which is actually my favorite picture of a duck ever. I think it's adorable. So, anyway, back to the slipper and Cinderella leaving. The servants have realized that the prince is probably not going to come down. And so they see that she left her shoe. And interestingly, Cinderella's glass slipper is actually standing on this piece of paper. Maybe it's another one of her hints that she wants to leave behind for us. It says, bending of light near a star and gravitational red-blue shift. Alternative explanation based on refraction of light. Well, light naturally bends. It refracts as it changes medium. So when light travels from air to water, it bends. This is a known phenomenon. It happens in the plasma atmosphere of our planet. There is a bending effect, and I'm sure you've seen when you look through water, the image is all weird. And that's because of refraction. So, as another quick little aside, I know this is going to sound super weird as well, but refraction of light always reminds me of bunny rabbits. Like, I know that sounds weird. Bending of light, where have I heard of that? You go, oh yeah, I remember hearing about the bending of light near a star in gravitational lensing. Right. Remember? Distortion of space-time is warped and curved by massive objects bending light as it passes through. This is my favorite picture of a bunny of a bunny rabbit. It's very cute. And it, wait a second. Oh, wait, crap. Is this my duck? Wait, crap. Was this the duck or the bunny rabbit? Or which one's which? I don't know. I can't tell which one's which. There's an alternative explanation for the, the phenomenon that we're observing right there. It could be either a duck or a rabbit. It's crazy. It doesn't remind me of anything else. Totally dissimilar to all other situations. And so the servants are kind of like, well, we're looking for the girl who keeps our prince grounded. Because when she's not around, he just sort of drifts away and goes a little crazy. And so the help, after seeing the article that the shoe was laying on, they pick up the shoe and they go, maybe we should use the actual slipper here. And the slipper is all of our observational evidence that we've collected over the years. We should try to fit that to all the forces that are in town, all the girls in town. So we need to go find the actual force that's responsible for keeping us on Earth. The servants come across this mysterious force right here. And they keep seeing her when they look out at the stars. They keep looking up at the stars, and this girl keeps showing up. And so they say, well, let's try to put the slipper on her foot. And so they keep trying to put it on, and they keep collecting more evidence and putting it on and collecting more evidence, and eventually the slipper fits completely over her foot perfectly. Not only are entire galaxies blank, but the faint, delicate threads joining galaxies are blank too. Everywhere we look in the sky, we find blank. And so the help, well, they put it on her and they say, wait, were you the girl that we've been dancing with? And she goes, yes, I am. And they go, but you don't look like gravity at all. And she goes, yeah, you guys just kind of called me that. I never said I was. How did you end up in the ball gown if you're here doing this? And she goes, well, I was magically transformed. And the servants, they say, well, magically transformed how? So I'm going to try to explain how we dressed her up as something she really isn't. This is my legally distinct Disney theme park ride. It's the world without gravity. So we're going to go through. It has some stars in it. Actually, no, it doesn't. The stars are for premium customers only, and you are not a premium customer. Let's meet the real star of the show here. So this is human error as the fairy godmother, and she is armed with the magic wand of theories based on false pretenses. Let's see what kind of damage the fairy godmother can do on our old innocent force here. Let's see if we can get some sort of transformative magic. And so I think what happened was that we accidentally dressed up electromagnetism as gravity. You're saying, well, that is probably not true. You go, I know. That sounds nuts. So you are fully within your right to say that that is gravitational lensing and follow all of the consequences that come with it. Let's review those real quick. So if that's gravitational lensing, then space and time are the same thing. Obviously they are, because we've observed gravitational lensing. The stars and galaxies should tear themselves apart by that same theory, and dark matter has to exist. This is the logical conclusion, is that the universe shouldn't exist, according to science. So you can argue with me that the universe shouldn't exist. Also, I'm just going to say the definition of insanity is doing the same thing over and over again, expecting different results. So you can keep telling me dark matter's there, you can keep calling it a duck. Totally allowed to do that. I can't stop you. But let's just consider for a second that maybe it's not gravitational lensing. Then what? What if it's not gravitational lensing? What if it's refraction? Well, what is it refracting through? What is the light? What medium is in space that light is passing through? Well, 99% of the universe is made up of plasma. Does plasma conduct electricity? It obviously conducts electricity. Plasma, at long range, electromagnetic fields dominate the behavior of this matter. The matter is plasma. So, where you have an electric current, you have a magnetic field. That's proven. And yeah, space and astrophysical plasmas, all sorts of places. Oh, did I mention it also refracts light? Did I mention that? Yeah, plasma refracts light, and it's 99% of the universe, and it conducts electricity. So, all things being equal, the simplest solution tends to be the best one. So, you can argue that the universe shouldn't exist mathematically because your math proves it, or you can maybe take a step back and try to consider things from an alternative perspective. So, let's take a step back. We may have had a bit of a misstep, and perhaps we got off on the wrong foot. But now that the shoe is on the other foot, maybe we can start to heal. We can start to take steps in the right direction. And so the servants are actually convinced that if the prince really starts to is introduced to the real force that actually controls the stars, the real force that he's been dancing with all this time, not just the pretty face of gravity, but the whole other layer underneath of who she really is and getting to know her, I think that they might make a grand union, a grand unification by the time it's all said and done. And I think it's going to be the most beautiful royal wedding that anyone has ever seen.
Maybe those three forces are actually just one force, and when we think there's three forces, it's because we're looking at that one force just from slightly different perspectives. Maybe. Here's something else which is amazing. These are the equations for the 12 matter fields in the universe, the neutrinos, the electrons, and the quarks. Each of them obeys exactly the same equation. Each of them obeys the Dirac equation. So again, you might wonder that, well, maybe there aren't 12 different fields. Maybe they're all the same field and the same particle. And the fact they look different is, again, maybe just because we're looking at them from slightly different perspectives. Maybe. So these ideas that I've been suggesting go by the name of unification. The idea that the three forces are actually combined into one is what's called grand unification.
So this is part one of my modest proposal of grand unification. So this is only part one, and part two has already been released. It's over here on my channel. Come check it out. And part three is coming real soon. So, and that one's going to be awesome. It's going to be filled with all sorts of stuff. So come on down, check it out. It's going to be great. So thanks. Have a great day. We can't rely on nature to tell us how nature works.